Alright, calm. This is AQA A-level chemistry topic 7 completely patterned. Yeah, we're gonna go through the whole thing, all the sheets for PMT sheet, and then yeah, fam, Redox. Yeah, let's get into it. So, state in terms of electrons the meaning of a term of oxidizing agent. Yeah, an oxidizing agent itself gets reduced, right? Because it needs to oxidize something else. So by oxidizing something else, oxidation is loss. Yeah, remember oil rig. Yeah, oil rig. Yeah. So oxidation is loss of electrons. Yeah. So therefore, to make something else lose electrons, you need to then gain electrons. Does that make sense? So therefore, the oxidizing agent, because it oxidizes other things, because it makes other things lose electrons here, it itself will gain electrons. So you can call it an electron acceptor. Yeah? Calm pattern. Next one. CR whatever whatever. Half equation for SO3 2 minus to SO4 2 minus. Now, someone will come here, they won't know, but because they watch life hacks, yeah, now they know everything in it. So what you can write here is I told you, you write the thing, the species here, on each side, like that. Yeah. And then you balance everything that's not oxygen and not hydrogen, yeah? Here, there's no the S is balanced already, yeah? So now what I need to do is I need to balance any oxygens here with H2O. So the left has three oxygens here, the right has four oxygens here. So I need to add one H2O to the left, yeah? Calm. Yes. Yeah? Now, what I need to do is I need to balance any hydrogens here with two H plus, with H plus here. So I've got two hydrogens here, yeah? So I need to therefore add two H plus to the right hand side, yeah? So 2, 3, 2 minus plus H2O, yeah, gives me SO4, 2 minus plus 2H plus, yeah? Calm. Yeah? Now, what I need to do now is I need to balance the charges using the electrons, yeah? So what's the charges on the left? We've got 2 minus here and nothing, and then we got 2 minus and 2 plus here. So therefore, I'm going to add 2 electrons onto the right hand side to make it also 2 minus. Now, the total charge on the right hand side is 2 minus, and the total charge on the left hand side is 2 minus, yeah? So this is the completed half equation, so I can write that down here. Cool. Yeah. Now let's do the second one, yeah? So the reduction of Cr2O7, yeah, to whatever, yeah? As you see, yeah, the SO3, the electrons on the other side, so that's oxidation, yeah? Alright, calm. Now let's do the same thing here for the other thing, yeah? So let's get through that. So Cr2O7 do minus goes to Cr3 plus here. Let's pick up the pace here, yeah? So quickly, yeah? So balance everything that's not oxygen and hydrogen here. So Cr, there's two Crs on the left, so I need to put another two on the right, yeah? So therefore I'm going to put 2Cr2O7, 2 minus gives me 2Cr3 plus, yeah? Calm. Now balance the oxygens here. I've got 7 oxygen on the left here, so I need to add 7 H2O to the right, yeah? So Cr2O7, 2 minus gives me 2Cr3 plus 7H2O, yeah? Calm. Now what do I need to do, yeah? Now I need to, now how many hydrogens do I have on the right? I've got 14, yeah? Because 7 times H2, yeah, is 14, yeah? So therefore I need to add the 14H plus onto the left. So therefore it's going to be 7 Cr2, yeah? Or 7, 2 minus, plus 14H plus, yeah? Gives man 2Cr3 plus 7H2O, yeah? Calm. Now I need to balance the charges in it. So look on the left hand side, I've got 2 minus, I've got 14 plus. Yeah, so it's a bit of a mad thing there, isn't it? Yeah, what I need to do here, and on the left I've got 3 plus, and that's so I've just got 3 plus, right? So therefore, yeah, if I've got 2 minus 14 plus and 3 plus here, yeah, it means I need to bring down the charge, you know? Yeah. So if you get a calculator or something, yeah, you can work out the charge, yeah. So 14, yeah, minus 2, yeah, 12, yeah. And then you obviously have plus. So it's gonna be yeah. So basically, on the left here, I'm gonna need to add 6 plus E plus if you deep it, yeah. Because look, so 6 E minus. Fuck, am I saying? Yeah, 6 E minus here. Because now look at that, it will be perfect, bro. Yeah. So now look at the deep it. I've got 3 plus here, but I've got two of them. So that makes 6 plus on the right hand side. Yeah. So I need to make 6 plus here. I've got 2 minus plus 14. Yeah. That's gonna make 12. And then 12 minus 6 here is going to make 6 plus here, yeah? So this is perfect, yeah? So write this one here now. So CR2O7, yeah? 2 minus plus 14H plus, yeah? Plus 6E minus gives me 2CR3 plus 7H2O, yeah? Come on. Yeah? And now I need to write the overall equation, yeah? So that's the part that people find tricky, yeah? So calm. So I've got these two equations here. I need to write the overall equation, yes? So to write the overall equation, yeah, just write both equations on top of each other, yeah? So write SO2, SO3, 2 minus, yeah? Calm. And then, the second equation, yeah? So CR, now I need to balance the electrons. I've got 6 electrons here, yeah? I've got 2 electrons here. So I need to top times the whole top line by 3, yeah? So to make it balanced, I'll become 3SO2 minus, yeah? Plus 3H2O, yeah? See that? See how man moved the little plus there, yeah? Alright, 3 here, and then 6 there. And then 6 here, yeah, because 3 times 2. Cool. Now you're going to write everything on the left, and everything on the right, yeah? So I'm going to do some cancelling, yeah? So I'm going to need to cancel 6E and 6E, yeah? And now write everything on the left. So 3SO3, 2 minus, yeah? Plus CR2O7, yeah? 2 minus, yeah? Now, I've got 14H plus on the left of this arrow, and I've got 6 plus on the right of this arrow. So 14 minus 6 here would be 8. So it's going to be 8 to the left. So I'm going to have to write 8H plus here, yeah? Does that make sense? Yeah? Whereas with water, yeah, I've got 3H2O to the left, and I've got 7H2O to the right. So the right is bigger. And then 7H2O minus 3H2O would be 4H2O, yeah? So then I need to write this, and then 3SO4 2 minus plus 2Cr3 plus 4H2O, yeah? Calm, you get that? So that's how you do it. You could also, yeah, what you could also do is you could write like, let me just check this is correct, yeah. Calm. What you could also do, yeah, is you could write everything on the left just on the left, yeah, and then everything on the right just on the right, and then cancel after, yeah? So bring everything to one side and whatnot, yeah, and then you'll see that it will give you the same thing, yeah? So this is the final combined equation, yeah? I'm not gonna write it there because you can use common sense in it. Alright, calm. Next one, yeah? So, compound 2. Which compound contains the chlorine atom with the oxidation state +4, yeah? So, let's go through it easy, yeah? Because even if it's wrong, you need to still get practice, you know what I'm saying? So, KClO4, yeah? KClO4 would be oxygen always -2. -2. K is always +1 because it's first period first group metal, yeah? Whatever. And then Cl, yeah, would be, that means Cl would have to be, because this is -8, and it needs to add up to -8 then. And this is +1, so this needs to be +7. Do you see that? So now the overall is 0. So there, chlorine is not +4. CCl, chlorine with chlorine always takes priority here, so it has to be -1. -1 times 4 is -4, and then this has to be +4, therefore, yeah? Calm. Carbon, yeah? And the chlorine doesn't have +4 oxidation state there. ClO2, again, -2 here, because oxygen is always -2, so that's -4. And now look, chlorine here has to be +4 to balance that, so this is the correct one, yeah? But I'm not like other man, yeah? I'm also going to explain the last one too, because you know what I'm saying? Good practice, and also like, yeah, you should just know. So this would be fluorine's always -1. Oxygen, yeah, is -2. So therefore, 2 times -2 is -4, plus -1, so it should be +5. Yeah? Easy. Alright, next one. NO2 minus ions can be reduced here into something. How many electrons are gained here? So this is pattern. What you can do is you can write it like this. You can write that actually. You can just do this as a half equation. Yeah? Let me do it below actually. Yeah. So I'm going from NO2 minus to NO. Calm. Okay, so what I need to do here is just balance it. So I've got two oxygens here. I've got one oxygen here. So I need to add another H2O to the right hand side here. So I balance oxygens with H2O here. Then I've got two hydrogens here, so I need to add two H plus into this side, yeah? So 2NO2 minus plus 2 H plus gives man NO plus H2O, yeah? Come. Hmm. And then what I need to do now is I need to balance it. So on the right hand side is neutral. On the left hand side I've got a negative here and I've got a 2 plus. So overall that's minus plus 2 plus, that's -1. So I need to add another electron to the right hand side. Now it'll become neutral. Yeah. So negative H plus and then plus E minus, yeah. That's gonna give 2NO plus H2O, yeah. Calm. So overall, how many electrons did the NO2 gain? It gained one electron, yeah. So therefore, I can say here it gained one electron, yeah. So A. Calm. Easy pattern, yeah. Let's go. Alright, cool. Question 4, yeah. Alright, question 4. Which compound contains chlorine in oxidation state of +1, yeah? Well, interesting, yeah, interesting, yeah. Let's go through them then. Cl2O4. So this one has obviously what? This one would have oxygen as -2. And then -2 to balance out would be +2 divided by 2 is +1. So it's A. Yeah? But listen, we're not like that, yeah? We're not like these other man, yeah? You need to go through all of them, yeah, to understand, you know what I'm saying? Yeah? Especially since I'm doing it here with you, yeah? So go through the second one too. Second one is gonna be if you don't want it, just skip it, you know? Yeah. Alright, calm. So second one is KClO3. So O3 again, so it's always -2. So therefore, and K I told you is always +1. So therefore, that's gonna be chlorine, yeah, because -6 and I've got +1, so it should be +5 with the chlorine, yeah. Calm. Next one, fluorine, yeah, is always -1. F, I mean, is always -1, and then I've got 3F, so this should be +3, yeah. Calm. And then the last one, yeah, CCl4, yeah. Cl is -1 in this case, yeah. Cl only changes when it's with oxygen and stuff like that, yeah. When it's not, it's inside the rules that I had as well. But when it's just like this carbon Cl4, yeah, it's just -1, and this would be +4, yeah. Calm. Just it aligned with the rules, yeah. Alright, calm. Next one, yeah. In which conversion is the metal reduced? So reduced, yeah, means that the oxidation number decreases, yeah. That means it was reduced, yeah, naturally, yeah. So in which situation was it reduced here? Come, so which situation was it reduced here? Let's just go through the oxidation states then, yeah? So Cr2, yeah, was so Cr2 would be here, it would be, so I've got oxygen is always -2, yeah? and then this that's minus 14, but then I need it to add up to the overall charge, which is negative 2, yeah? So therefore, CR has to be 6, because is 6 times 2 would be 12, yeah? And 12 minus 14 would be minus 2, yeah? So that works out, and then here, it'll be the same shit, so minus 2, and then, that'll be minus 8 here, so therefore to add up to minus 2, this has to be plus 6, so here, it didn't get reduced, yeah? Nothing happened to the metal here. MnO4 2 minus here. So again, here's negative 2. So that's negative 8. I need to add up to negative 2. So this must be plus 6. Yeah. Come. Again, here, negative 2 on oxygen here. 4 times negative 2 is negative 8. And negative 8 has to add up to minus 1. So therefore, to combat negative 8 to make it add up to minus 1, this must be positive 7. Yeah. Because positive 7 minus 8 would be minus 1. Yeah. So therefore, this was oxidized actually. Yeah. This was not reduced, yeah, because oxidation number increased, so it can't be that one, yeah. TiO2 minus 2, 4 plus 4. Yeah, you get that, yeah? Easy. Minus 2 times 2 is minus 4. So then Ti must be plus 4 to balance that, yeah? O3, so that's minus 2. Minus 2 times 3 is minus 6. And then I need to add up to 2 minus, yeah? So it's also going to be plus 4, right? Yeah, 4 minus 6 would be minus 2, yeah? So that's TI didn't change it there either, yeah? So it has to be D, yeah? But let's just see D anyway, yeah? Minus 2. So minus 2 times 3 is minus 6, yeah? And to make it add up to negative 1, it has to be plus 5 then, yeah? Because 5 minus 6 would be negative 1. Yeah, the ion is, by the way, is what I'm adding up to, yeah? And then VO2 plus here, well, dpit fam, this is negative 2 again. And then V has to be what? Has to add up to 2 plus, so I need to be plus 4, yeah? Because 4 minus 2 would be positive 2. Yeah, so therefore this got reduced. It went from oxidation state 5 to 4. That reduced, yeah? So it's D. Alright, cool. Question 6 here. Which equation does not represent a redox reaction here? Alright, calm. So, easy. So, magnesium, yeah, oxidation state is 0. Elements have 0 oxidation state. 2 HCl, H is plus 1, Cl is minus 1. MgCl2, Cl would be negative 1. Negative 1 times 2 would be negative 2, so Mg has to be positive 2. If that makes sense. And then H2 is 0, yeah? So this is a redox reaction, bro. Yeah? Magnesium got oxidized. Cl got Cl got H got reduced here, and Cl stayed the same. So that's a redox reaction here. B H4. So this is negative 1, plus 1. Hydrogen always takes priority. Yeah, always positive 1. Yeah. So yeah, positive 1 here, and then C becomes negative 4. Yeah, and this is in a hydride. Yeah. So when it's with the metal will take priority. Yeah. But here it's positive 1, and then C has to be negative 4. Therefore, yeah. And then this is just the element, so 0. CO2, so O has to be negative 2, so negative 4, and then plus 4 on the C. And then H2O, yeah, has to be negative 2 and plus 1, because I told you H always plus 1, yeah. So therefore, what happened here? Well, this is also redox, because carbon got oxidized, oxygen got reduced, went from 0 to negative 2, and yeah, and hydrogen stayed the same, and carbon went from negative 4 to 4. So therefore, this is redox, yeah? So it's asking which one is not redox, yeah? Calm. Next one. Fe plus Cu SO4, yeah? Fe is 0. Cu, whatever is, O is negative 2. So that's negative 8. And then copper has to take priority. Copper is always plus 2. Because always you do it, apart from what's in the rules, yeah? You do it based on the group number, yeah? Like what ion it would form. And then sulfur can change it. It will be plus 6 here, though, yeah? I believe it makes sense here, yeah? Plus 6. And then Fe2, SO4, yeah? Again, this would be negative 2. That's negative 8. Fe will be plus 2. So then plus 2 and negative 8. To balance that, I need to add 6, so then it becomes equal again, yeah? And then Cu is 0, yeah? So this again is a redox reaction because Fe went from 0 to plus 2, so it got oxidized there. And which one? Cu went from plus 2 to 0, so it got reduced, yeah? And S didn't change, and O didn't change, yeah? Next one, D, yeah? So this one has to be the one that doesn't represent redox, yeah? So negative 2 on oxygen, yeah? So plus 2 on copper. then -1 on Cl, so +1 on H, and then -1 on Cl, so +2 on copper. And as you see that copper went from +2 to +2, didn't change. Cl went from -1 to -1. And here oxygen's going from -2 to -2. Yeah? And +1 to +1 for hydrogen. So nothing changed here, yeah? Therefore it's this one that's not redox, yeah? Alright, calm. V2O5, yeah, can be used as a catalyst in the whatever process, yeah? The contact process, yeah? So in the contact process, yeah, what you're doing is you're using SO2, yeah, if you remember the equation, to form, yeah, SO3. Yeah? So you go from SO2, yeah, to SO3, yeah? So what does that, bro? B is going from SO3 to SO2, so straight away B is not correct, yeah? So we can rule that out, yeah? Now we just got A, C, and D, yeah? So now we just need to look at which one vanadium is oxidized, yeah? So let's look at vanadium here in A. In A, yeah, vanadium is what? Is V2O5, yeah? So that's -2 for oxygen, yeah? That's -10 now. And to balance out, V must be +5, so it can be 5 times 2, which is +10, yeah? And then what about here? Here you got -2. -2 times 2 is -4, so it has to be +4 for vanadium here, yeah? So from +5 to +4, yeah, that's a discrepancy, you know what I'm saying? That's reduction, that's not oxidation, yeah, so it can't be A. C, yeah, goes from what, fam? Goes from VO2, so that's -2. -2 times 2 is -4, so therefore V has to be +4 to balance that, yeah, to counteract that, yeah, like the Shatler principle thing, yeah. Take the piss. Anyway, +4, yeah, and then oxygen has to be just oxygen, and then V2O5, yeah. This one, as we saw earlier, V2O5 has -2 here, and it has +5 here, which means therefore this one got oxidized. It went from +4 to +5, yeah. So vanadium got oxidized, increase in oxidation number, yeah. Calm, easy, mate. Yeah. V2O5, yeah. That one's going from what to what? V2O5 is +5 and -2, yeah. We know by now, yeah. This is became standard, yeah. And then VO2, yeah. This we know it as well. This is -2 and +4, yeah. So again, this one got reduced here. Went from +5 to +4, yeah. Alright, calm. Next one. Which of these is a redox reaction, yeah? So redox, again, something has to be reduced, something has to be oxidized, yeah? This is obvious, it's very bait, yeah? But what I'm gonna do, yeah? I'm gonna tell you right now which one it is, but just skip to the next question if you don't want to see like the other ones, yeah? But I'm gonna leave it in just in case and some people want to see, yeah? So obviously, to me, it's straight away obvious. It should be to you as well. It's obviously D, yeah. D has elements that are above 0, 0. Then when they make a compound, yeah, Mg is gonna be +2, yeah, because that's what it is in standard state, yeah, +2, and therefore sulfur is gonna be -2. So therefore, yeah, magnesium went from 0 to +2, and sulfur went from 0 to -2, yeah. So it's definitely that one, yeah. Magnesium got oxidized, sulfur got reduced, which is normal. That's what happens, yeah. In an ionic bond, yeah, metals lose electrons and they give it to the non-metal, yeah. So the non-metal gets oxidized, reduced, and the metal gets oxidized, yeah. But let's just go through it as well, yeah. You can skip if you don't want to see this. So CaO, yeah, -2 here, yeah, and then Ca would be +2, yeah. SiO2 it would be -2, and then Si would be +4, yeah? Because that makes sense. So -2 times 2 is -4, so Si has to be +4 to counteract that, yeah? CaSiO3, yeah, is -2, so -2 times 3 is -6, yeah? -6, so therefore calcium is always +2, so therefore Si has to be +4 to counteract that to make it go up to -6, yeah? Because 2 plus 4 is 6, yeah? And as you see, nothing changed. Calcium stayed as +2, Si stayed as +4, nothing changed, yeah? So it can't be A. B, H2SO4, yeah, so O is -2, so -2 times 4 is -8. H always has to be +1, so therefore I've got 2, and I've got -8, so therefore S has to be +6, yeah? Calm. NO2, so oxygen is always -2, and A has to be therefore +1, which makes sense because it's group 1 metal, yeah? So +1 times 2 is 2, counteracts -2, yeah? Here I've got -2 for SO4. I have to be +1 for that. So 2 plus and -8. So therefore, I have to add 6 here to counteract that. So S didn't change. H didn't change. NO didn't change. Here's -2 and +1. Yeah, so nothing changed here. Yeah? So it's not redox here. Alright, C. Has to be -1 because sodium is always +1. So this is -1. H2SO4. Um, Again, -2 for oxygen, -8. Then has to be +1. So therefore, I've got 2 plus and I've got -8. So I need to add 6 to balance it onto S. And then here, same thing. So sodium HSO4 here. This is an interesting one, yeah, but still doesn't warrant it. So -2 here is -8. Sodium has to be +1. Everything has to be +1 here, yeah, or plus something, yeah. So H here has to be +1 because it's not on its own with the metal here. And then S has to be therefore uh +6 here. Yeah, +6 +1 is +8, and then that's -8 here. HBr has to be obviously +1, -1, yeah. So again, nothing changed here, yeah. So it has to be D. Calm. Question 9. Which species is the best reducing agent, yeah? So reducing agent means what? Reducing agent, yeah, means that it has to reduce something else. So it itself has to be oxidized. So what that means, it has to lose an electron, yeah? And so first of all, yeah, what's going to be easier to lose an electron? An atom or a negatively charged ion. Obviously, a negatively charged ion, because that means that it already has an extra electron, right? So it'll be added repulsion, it'll be added whatever. Yeah, so it can't be A and it can't be C, yeah? Now, difference between B and D, yeah? Deep here. If I go down the periodic table, yeah, down the group here, there's more shells, there's more shielding, there's a higher atomic radius. So therefore, it'll be easier to take, let's say I've got like something like that, yeah? Or I've got something like that. What's easier to take an electron from all the way out here, yeah, where the electrostatic attraction is very weak, yeah, or one from this element where it's very close, yeah, obviously from the weaker one. And iodine is far further down, yeah, than chlorine, so therefore iodine is a lot further down as well. So therefore iodine is the easiest to take an electron from. Therefore, it's the easiest reducing agent, yeah, because it reduces other things, yeah. Alright, calm. Listen, I know I said I'll go for all of them, whatever, yeah, but listen, man. You need to work smarter, not harder. Yeah, this is all long, bruv, and we already know Mg plus S is the oxidized one. It has a redox equation here, so I already know that's gonna be oxidized here. So I don't need to do shit here. Yeah? It's obviously that. Yeah. Listen, even if you didn't know it, yeah, from previous question, you can just tell, man. Yeah. Sometimes you just need to look at them, bruv. Like, what's the bait one? It's that one. Oh, 0, 0, and obviously, yeah, +2, -2. Yeah. Calm. Question 11. Yeah. Which reaction is hydrogen acting as an oxidizing agent, yeah? So hydrogen has to act for hydrogen to act as an oxidizing agent, yeah? It needs to therefore be reduced. So it's reduced when it combines with the metal. Again, it's a case of work smarter, not harder. Yeah, it's obviously D. Yeah? Goes from 0, 0 to +1, -1, yeah? H has to be -1. This is a hydride type thing, yeah? Where you got H and just a metal on its own, yeah? Calm. So again, just work smarter, not harder here, yeah? Don't be dumb and think about this shit, yeah? Alright, calm. Question 12, yeah? Uh, which of the following shows chlorine in its correct oxidation state? So just this one, just find each one in it. So nearly done by the way as well. Crazy. I think there's only 14 questions or something. Calm. So basically, yeah, HCO, yeah. So therefore, -1, +1. Calm. Okay. O3 is gonna be -2. So that's -6. This has to be +1 because group one, and then Cl has to therefore be +5. Because 1 plus 5 equals 6, yeah? So it counteracts that, yeah? HClO, that's -2. H has to be +1. So Cl therefore has to be +1, yeah? So which one does that align with? +1 plus 5 and whatever is C. -1, +5, +1, yeah? Cool. Which of these shows nitrogen is in its correct oxidation state, yeah? So, um, yeah, so again, you just need to do the same thing, yeah? So, H is always +1, so +1 times 3, so it has to be -3 for nitrogen, yeah? And then N2O, O has to be -2, and then that's going to counteract it, so that there's going to be +1. Yeah, because two pluses against -2. Yeah, and then HNO2, yeah, it would be O would be -2, so that's -4, and then H has to be +1, so therefore to make +4, N has to be +3. Yeah. Cool. So therefore, it's which one? It's B in it. Yeah. -3 +1, +3. Yeah. Calm. The final question. Yeah. Easy, easy, man. I'm telling you, man. PMT ain't got nothing on, man. We used to pipe down. Cool. So, which of these is not a redox? So let's look at this. So Cu2O. Cu is going to be +1, -2. Yeah, -2 is oxygen, and then that's +1 times 2, which counteracts it easy. Yeah. SO4 minus, that's -2 here. So that's -8, and then H has to be +1. Always +1, yeah? So therefore 2 plus and -8. So I've got to have +6 here, yeah? It's getting pretty repetitive by now, yeah? You know everything by now, yeah? But again, when it gets repetitive, yeah, that means that you understand it fully, which is a good thing, yeah? And then -2 times 4, yeah, that's -8, yeah? And then Cu is going to be +2. Yeah, it's always +2. So +2 and -8, so S is going to be +6. Cu is 0 here. And then C2O, H2O, yeah, would be -2 and +1. So did anything change here? Yeah. Which of these is not a redox? Well, Cu got oxidized and reduced. So this is actually disproportionation, which counts as a redox reaction, yeah? So Cu got, look, it got oxidized, yeah, to 2 plus, to +2 from +1. And then it also got reduced to 0 on the right-hand side, yeah, from +1 to 0. So therefore A is a redox reaction, yeah? Now B, -2 on the O, +2 on the Mg, -1 on that, +1 on the hydrogen, -1 on the Cl, +2 on the Mg, because Cl -1 times 2 is -2, so +2 Mg, and then -2 on that, +1 on that. So this is not a redox reaction. Nothing happened here, bruv. Yeah, Mg went from +2 to +2, Cl went from -1 to -1, O went from whatever to -2 to -2. Nothing changed here. So that's B. Yeah, I'm not gonna go for the other two. Yeah. Alright, that's it, man. Yeah. Yeah. Good luck.